Good evening, everybody, and thank you for coming. Tonight's program is actually the fourth event in the adult summer reading program. And for those of you who don't know, we have an adult program just like we do a kids program, but for adults it's easy. You read 5 books, or you read 3 books, and come to 2 of the events, of which this is the 4th. So there are more things you can choose from, and you don't have to be an adult to get the credit for coming. You can be a teen or a kid and come to this event too. But if you haven't signed up for the adult summer reading program, there's handouts on the table in the back. My name is Beth Fisher, and I'm the program librarian here at Iowa City Public Library. And our guests tonight, this is actually the 3rd time they've helped us with the adult summer reading program. This past Saturday, they led the tours out at the Devonian Fossil Gorge, which was a lot of fun. And Ray Anderson here was our speaker 2 weeks ago for the Introduction to Rock Hounding program that we've had. And if you've been upstairs, you'll suddenly see a big glass case right in your way as you hit the top of the stairs. Those are all Ray's rocks. And then out on the way to the children's room is another case full of fossils. Those are from the university. So check those out if you haven't already. Our guests tonight are Ray Anderson. Where'd Marv go? Oh, he went over there. Marv Houg. I screwed it up. Houg. Marvin Houg. Marvin is the president of the Cedar Valley Rocks and Minerals Society, and Ray is the vice president, amongst all sorts of other geologist titles that they could both stick at the end of their names. You know, it goes on about this long. And they are here tonight to talk about Iowa's state rock, the wonderful geode. So I'm going to let them get on with it. Thank you for coming.
Okay, thank you all for coming is right. Okay, as you might know, the geode is Iowa State rock, and it's really quite an interesting rock, and so I thought I'd talk about it a little bit today and tell you a few of the interesting things why I consider it mysterious. So what is a geode, first of all? That comes from the Greek. G is for earth, and odes is like, so it's earth-like, so it's round like the earth. So the Greeks must have known the earth was round back then. Usually hollow, usually hollow spheroidal rock with crystals lining the interior wall. So that's a definition of it. Although that word is really applied to a number of different types of rocks, and there's kind of a thin line between geodes and agates. I tend to kind of lump a lot of these things together, but we'll talk about them. Hello? There we go. That term's been applied to crystals that form in gas pockets and lava flows, and crystals that form in a whole lot of other ways. But the classic ones are... Am I doing something with this? It keeps going in and out. Okay. The classic ones, my favorite ones, are the ones from Keokuk. They're the most interesting. Okay, so the geode became the Iowa State rock officially in 1967. Declared that it should be a state rock.
Do you mind?
Nope. There we go. Does that work? Yeah. Okay. The legislature decided they want that for a state rock because it was among the most rare and beautiful of rocks, and Iowa was world famous for it. And that's really pretty much true. They thought about doing coral fossils like these, for instance, or limestone, but fortunately, geodes won the day. Lots of people confuse these things that we geologists call vug fills with geodes. Now, this is a vug fill. What a vug is just a hole in the rock. And lots of times groundwater will move through and fill these with minerals, like that is calcite in that case. Looks a lot like a geode, except that this material is made of the same material as the rock around it. So it's not going to weather out to form a nice round geode like these guys do. You can also find these kind of vug-type things in shale, and this is another one with just got a calcite lining around it. But sometimes the ones in shale, the shale being softer than the limestone, actually do weather out. And so you get something like these ones we find up around Jessup. These are all calcium carbonate, all limestone. as opposed to most geodes that are a little different. And this is what the makeup of most geodes are. They have what we call a chalcedony rind on them. So that chalcedony is a type of quartz. It's much harder than the limestone that encloses it. So that can actually weather out of the limestone. And you end up with something like this. This is a geode like that that's just been split in half. You see the two halves. More often than we like, you find these things that are completely solid. They don't have a void on the inside. They're often called nodules, although I just as soon call them just a solid geode, because geodes are pretty special, whether they're solid or not. A lot of other things have holes in the middle and are somewhat spherical, so technically could probably be called geodes. This is what's called a septarian concretion. It's just a bunch of minerals that move through and formed inside of this shaly limestone. And sometimes these will form like this and actually have voids in them. So there's a sort of a subspherical thing with a void in the middle, so technically that fits the definition of a geode, as does this. This is just a piece of ironstone. It's iron and clay kind of fit together, and the way it formed ends up with a hole in the center. Same with these clay stones, and then you can get these really nice ones that are made of some other minerals, but those are pretty rare. You have to go out to Arizona to find those. Probably the most common type worldwide is what we call vesicle fill in volcanic rocks. Here's how that happens. You get a nice lava flow out on the surface and it cools down like that. But as it's cooling, you get kind of an interesting phenomena. When that magma, that molten rock is in the ground, it's under a lot of pressure. And so there's gases that are trapped inside of it. When it comes to the surface, it releases those gases. And so the gases rise to the surface as little bubbles, kind of like shaking up a bottle of Coke will do the same thing. Then these little bubbles just get frozen into the surface when the rock hardens. So you end up with something looking like this. This is a lava flow. The center of it is down in here. See, it's real solid. And then as you get toward the top of it, more and more bubbles. Comes in a variety of different sizes and shapes. This is another part of a lava flow, just with a lot of these bubbles or vesicles at the top. And there's another one. Well, sometimes these vesicles fill in with other rocks and other materials. Groundwater carries material through the rock and it precipitates in there, and you're liable to get something like you do here, which are agates. This is quartz that formed inside of those vesicles, so those are called agates because they're banded. So, while we're talking about agates, we can talk about them. This is a very nice agate. You could call it a geode, I suspect, because it's round with a hole in the middle and crystals growing in it. These guys, as I said, form in vesicles, and let's see how they form. We look at this vesicle right down here in the corner. Groundwater kind of sneaks its way through cracks and stuff, and it'll fill that up, and the groundwater has some minerals in it. The minerals will precipitate on the outside of that, and you get a little ring of something. Then pretty soon it'll change chemistry, and you get something else moving through, and something else moving through, and then pretty soon you end up with a rock with a lot of bands in it. When you have a quartz rock that's banded like this, you can call it an agate. These bands kind of form from what are called nucleation sites on the side of the vug. So here's a hole in here. This is air or water or moisture or whatever in there, and this is the rock surface. These little things serve as nucleation points, and the crystals grow outward from there. So if there's just a few areas around where it's growing from, you kind of get these big areas like that, and you'll end up with an agate that looks something like this. Big loopy bands. If there's a lot more of these nucleation centers around the side, it'll be more of a solid bands like that agate there. Again, a little hole in it. You want to call it a geode, you could do that according to the dictionary. The very best agates, the ones we like around here the best, are the Lake Superior agates. They come from up in Lake Superior. Very beautiful rocks. And they form in lava the same way. These are lava flows on the shore of Lake Superior up in Minnesota. And all these little white spots here have nothing to do with all the seagulls around there. These are actually little vug fills. Look a little closer, you see they look like that. Now, this quartz is much harder than the basalt rock that it's in, so nature, as it erodes things away, will erode away the matrix from around the outside of those agates, and the agates will roll off onto the beach like this, get rounded or tumbled in the lake. So if you go looking at the beach, you'll see rocks that look like this. If you look close, you'll see a few that look like that, and you've actually got some Lake Superior agates there. Of course, some of the Lake Superior agates end up being hollow on the inside too, sort of round, hollow with crystals growing in it. We'll call it a geode. Another famous type of geode are these thunder eggs. Thunder eggs form in lava much the same way, except there's a little difference in these things. Oh, yeah? There we go. Shows you some of the variety of the thunder eggs that you can find. And I think that most of those that we see around here come from Washington, Oregon area, don't they, Marv? Yeah, that's what I thought. You see that they're named usually after the ranch or the outcrop that they're found in. And you see there's a variety of different holes that are filled in. Some get layered in like that before crystals form. Some form little stalactite type shapes. There's all sorts of things like that. And these are how those things form. They form in a lava flow, but this is a rhyolite lava flow. In other words, it's got more quartz in it. It's real viscous, very thick in it, is a reddish colored lava. So the lava looks like that, and that's what this lower unit is here. Then at the top where the bubbles rose up, groundwater worked on that glass at the very top and turned it into this material called perlite. And perlite is this kind of white stuff, and the vugs filled with these thunder eggs that look something like this. So this is a landscape where you find these sort of things, and this is a typical quarry for thunder eggs. You see, these people are kind of digging them off the side of the cliff there and in the ground probably. There's some girl that's got a nice prize. Mexico has a lot of really nice agates. Again, all formed sort of the same way in lava flows by groundwater filling in these holes. Very beautiful colors. This is a Mexican coconut geode, and there's one of those up here that you can take a look at after the talk if you'd like. Here's a couple more varieties of the same type of thing. Brazilian agates are maybe some of the most colorful and beautiful. Again, here we got a little hole in the middle, not too many crystals in there, but I could get away with calling that a geode. I'm pretty liberal on that sort of thing. These guys are really beautiful, and when you go into a store and you see a slab or something that's cut or something like this, you can bet they're either Mexican or Brazilian agates. They're very beautiful. There's one with a bunch of quartz crystals growing into the center. Now, another type of geode that is very cool are these Amethyst Cathedrals. These are, again, a bubble, except in this case, the lava cooled on it as the bubble was moving up slowly. So instead of just a round thing where the bubble was, it actually left a trail behind it, and you end up with a kind of a hole in the rock that looks like that. They get very big, and they get much bigger than this even. You would pay through the nose for one of these. These come from an area in Brazil, sort of on the Brazil-Argentina border, that are called the piranha traps. And what these rocks are rocks that spewed out of the earth when the Atlantic was opening. And so there's a lot of those. This area is very famous for a nice resort. There's a waterfall down there. It's very famous with some with a resort there. And this is the sort of thing that you find these in. Again, we have a lava flow with these kind of vugs in them. And it forms something like this. There'll be a void. And the first thing that happened on these was the groundwater carried this kind of a greenish clay through that's called celadonite. And that kind of lined the inside of that rim. And then after that, chalcedony, quartz, and amethyst formed in the void. And you end up with something that looks like this. Now, the amethyst is a kind of quartz, but it's a purplish color, and this is a picture of some quartz crystals that grew with iron and magnesium in it, and sometimes this water that the quartz was growing in had a little more iron and magnesium, and so it turned purple, and other times it didn't, so it would just be clear. So if you look at these crystals closely, you can see something like that frequently. These are the kind of mines that they dig these things out of. little holes in the lava flow, and you get in there with a miner, and he's got a jackhammer here, and he can hammer that thing out, because that little coating of clay on the outside means that thing's going to pop right out when they get the rock around it, because that clay doesn't stick to the inside parts. So that'll form a geode that looks something like this. There we go. If you're a wholesaler on those things, you can do something like this. You can have a whole lot of them. Now, amethyst is purple, but if you heat it up, if it gets next to a volcanic lava flow or something like that, it can turn to citrine, which is this yellow color. Well, these are kind of hard to find in nature, but these guys figured out that if they take these purple things and put them in an oven and cook them just right, you get pretty citrine. Now, here's my favorite. These are Keokuk Geodes. These are the ones from, not necessarily in the town of Keokuk, although you can see them there, mostly around the area, maybe about 50 miles or so every way around the Keokuk area. Now, this is a geode that's on display at the Iowa Geological Survey in Trowbridge Hall, and this has 8 different types of minerals in it. This is where the top was broken off here. If you want to see the top piece that broke off, you'll have to go to Iowa Hall there. It's in the display case in the front lobby of Iowa Hall, so you can see both pieces of that geode if you want. Here's where the Keokuk Geodes are found at. These are the kind of locations all around here. This is that quarry in Henry County I was telling you about, I think, Marv. And I haven't been there for so long, I don't know. So some of them actually come from Keokuk, but most of them are kind of from around that area. They come out of a particular rock unit. They come out of Mississippian age rocks. That's these down here. And if we look a little closer, this is a stratigraphic column, by the way. This shows all of the various rock units in Iowa and their names, et cetera. So if we look a little more closely at that Mississippian section there, what we see is the Warsaw and St. Louis, Warsaw and Keokuk formations. That's the place where you find the geodes, right in that unit there. And if you go to an outcrop, like this is a road cut that goes down to the Mississippi River to a barge terminal just north of Keokuk, and you can see the beautiful rocks here. That's the Keokuk limestone down below there, and this is the Warsaw Shale right here. The geode zone is right about in that area there. So if you walk down this road a little bit and go up and look at the rocks, you see here's the rocks with the actual geodes in them. This is another one. This is where they made a cut to build the Burlington water plant, and they cut through some of these rocks, and they actually had geodes in the rocks, and so when they built the water plant, they actually left that rock exposed inside the water plant so people could come in and see geodes. This is just on a walkway going into the building outside of it. So how do these geodes form? This was finally worked out by a guy named Robert Maleva from Harvard University in 1987. And here's what he came up with. The Keokuk Formation is a limestone that's turned into a dolomite, and on top of that, the Warsaw Shale was deposited, a little bit of limestone in the middle of the shale there. And then on top of that is the St. Louis Formation. Well, this records a series of the oceans retreating from Iowa. In other words, the ocean at this particular spot was getting shallower as it covered the area. So finally, it got to a place where it was really shallow here, and it formed an evaporite basin. That means that the seawater would evaporate from this basin, and some more would come in, and it would evaporate. And so what it did was accumulated a layer of gypsum on the very bottom of that basin. Well, the groundwater and the water from the ocean dissolved that gypsum and carried it down, and it formed these nodules. So these are gypsum nodules in the shale, and then it filled in some of the voids in the dolomite. So these are gypsum nodules. The gypsum nodule looked something like this, and in the ground, a layer of this chalcedony, of this quartz, formed around it when more groundwater moved in. So you had an anhydrite nodule, a gypsum nodule, surrounded by chalcedony. Well, it wasn't completely surrounded. There's cracks in that chalcedony too, so groundwater slowly moved in, dissolved away that gypsum, and deposited a whole raft of minerals, in this case, a lot of quartz. The minerals in the Keokuk geodes are one of the things that really is amazing to me. There's an incredible variety of minerals found in these geodes. And T.J. Ramsey here, he runs First Crack Geodes out of North Liberty. He's on the internet there. He sells lots and lots of geodes and has looked at a lot of them. And he looked at these minerals to try to see how much we have of what. Now, first place, we know there's 20 different minerals have been identified in geode, plus crude oil in some of them. And there's a few more minerals that we suspect are in there, but they haven't really been formally published yet. But so there's a huge variety of minerals, and where some of these things come from, I don't have the slightest clue. But JJ went through and looked at a lot of these, and he figured out which were the most common and which were the rarest minerals to find in his geodes. Well, here's the most common. The larger numbers are the more common. Most common are these solid geodes, and that's, no void in them. Those are the kind that you don't like to find. That's the most common, of course. And then quartz and on down through these things. Oil geodes are pretty rare. The black calcite geodes are the rarest, according to him. So let's look at a few of these geodes. I got quite a few slides here to show you pictures of geodes and some of the things that's in them. This geode here has 6 different minerals in it. Aragonite is a kind of a calcite, calcium carbonate-like things. This one's got barite in it. Here's a black calcite one. This is one of the really rare ones. This one's got what's called a beryl calcite in it. That's a particular crystal structure of calcite that sort of reminded somebody of a beryl, so they called it that. Brown and black calcite, as well as clear calcite, ferro and dolomite, more brown calcite. Some of them have this sort of an iridescent sheen in it. Those are really cool. I've actually never found one like that, but they're really neat. Some of them have kaolinite, which is a kind of a clay, and these funny crystals of calcite there growing in it. Some can have hematite, which is iron oxide. It gives it that reddish color. And calcite with a blue rind around it. Some more of those iridescent ones. Some of these are called citrine. Now, citrine is a particular type of quartz, and this technically isn't citrine. Citrine is yellow quartz. This is clear quartz with a little bit of iron oxide coating on it that makes it look like citrine, but it's called citrine anyway. Once in a while, you find a fossil, like this is a horned coral that was buried in the rocks, and it got turned into a geode. It got dissolved away and replaced by the gypsum and then turned into a geode. So it looks like a regular horned coral, except it's kind of puffed up a little bit. And all these fossils you find that are turned into geodes are kind of puffed up a little bit. This is a close-up of this bronze iridescent one. I thought it was so pretty. If you really look inside of there, it's really, really beautiful. Pink calcite, gold sheen calcite, chalcedonian calcite, light smoky quartz. So they call this smoky quartz. Not technically, again, but it's got a little bit of a smoky appearance to it. Pink calcite, pagoda. If you look at the shape of some of these crystals, it looks like a little Japanese pagoda. So those are pagoda crystals. Some of them have iron pyrite, fool's gold in them. Get these little quartz bridges that kind of grow across there. Sphalerite is a zinc sulfide. How does zinc get in there? Who knows? Barite, a barium carbonate. How does barium get in there? Malachite, which is a copper oxide. How does it get in there? Where's the copper coming from? Who knows? So you have these sort of large dog's tooth or skeletahedron crystals of calcite. Marcasite, you have this botryoidal chalcedony there. I really like that. I love that word. Botryoidal is my favorite geology word. It just kind of rolls off your tongue. Botryoidal, that's these kind of round, curvy shaped things. Some of them actually have petroleum in them. This is oil that came out of the Illinois basin. You find these in Illinois only, as far as I know. And you crack them open and that black crude comes running out, and man alive, it really is nasty stuff. You get it on your clothes, it never comes out. These are called snowball quartz because it looks like it's got a little snowball inside. It's just another cluster of quartz crystals that formed in there. And sometimes they can break open and you'll see they're hollow and you kind of get multiple layers of quartz. There's one of those right up here you can take a look at later. Red quartz, some more botryoidal stuff. Root beer calcite, guess what color that is? These geodes can get pretty big. This is the biggest one that I've seen. I'm sure there's bigger ones around. Marv probably has seen a lot bigger ones than that. But this is one that a fella donated to the University of Iowa one day. Said, I've got this giant geode, lived down by Keokuk. Now I'd like to donate it to the university. So I went down and got it. And it's a nice geode. Okay, where do you find Keokuk geodes like this? Well, you can find them in riverbeds and creek valleys if you know the right place. They just look like round rocks, but you have to know the right place to go. Otherwise, you'd be cracking open a lot of round rocks that aren't geodes. Another place you can find them is in geode mines. There's actually places where you can pay them money, pay them, what does it cost, $20 a 5-gallon pail or something. Go in and collect all the geodes you want. And that's kind of fun. This is one in St. Francisville, and there's another one over in Illinois. So the town of Keokuk sponsors this event every year called Geode Fest. This year's one's going to be in September. You can go down there and you can get with the group and you can go to these mines. You can collect all the geodes. You can buy things. You can get people to help you split them open. You can get all kinds of fun to be had down there. So make a note on that if you're interested. That's a good time to go there. Otherwise, and this is what you'll see a lot of vendors like this selling various type of things, and who knows who you'll run into down there. This is Marv, our president there, and with his geodes. So what they'll do is they'll haul you out there, or you can drive yourself out to one of these mines, and then you just spend your time loading up all the geodes you want. If you're real fortunate, your kids won't find one of these. Because, man, that is a big geode. That sucker is heavy, heavy, and I wouldn't want to be moving it. So you can go to these places yourself if you want. You can contact them, make arrangements to go out there, or you can go with the group. And our club, the Cedar Valley Rock and Mineral Society, makes a trip to collect geodes probably a couple times a year. And this is our club is the biggest club in the state. We meet up in Cedar Rapids on Tuesdays, the third Tuesday of every month, and everybody's welcome to come visit us and see what you like, or come join us if you like, and we can take you into these mines and collect things. As you're on your way down there, you might want to stop in West Burlington. Our Lady of, our St. Mary's Church there has this Our Lady of Grace grotto, and the grotto is made up entirely of cracked geodes. It's really quite a sight. It's right alongside the road there. It's pretty easy to get to. Give it a try. Well, a lot of people have accused me of having rocks on the brain, so I got an x-ray one day just to find out. And sure enough, geode brain. So I'll be up here for a while. I'll be glad to answer any questions. We've got some geodes on display up here. We've got some small geodes that we're actually going to crack open. And then on the back, I've got a bunch of material that is handouts, and you can welcome yourself to take some of those if you like. We've got our rock show coming up next year, and geodes is going to be the theme of our rock show, so we'll have lots of wonderful displays of geodes for sale, all that kind of stuff. Plus, that's a combination with the National Association of Mineral Clubs, so it'll be a national meeting associated with that. So it's a good time to get up there. You get a flyer on that down here. We also have a rock auction coming up in September. That's just what it sounds like. It's an auction. It's when people that have collections of rocks want to get rid of them, or dealers have a bunch that want to sell them to other dealers or just to John Q. Public. And so you can go to that rock auction if you want, and perhaps get some geodes too.
Now, for questions, you have the question mic. So you need to talk into this.
Okay.
And I'll take that. Or she can mic.
Okay, well, let me answer a few questions first, and then I'll invite you up to here, and Marv will crack some geodes for us.
Yep, but you got to ask the questions in this so the people at home can hear your question.
Or get a different mic?
Because we're being videotaped.
Stand here, that's fine.
Okay.
What is your favorite color of geode?
Well, I kind of like a lot of those really pretty ones that come from other countries. You know, they have all the color bands in them and stuff. So I don't know. I expect that if you're talking about Keokuk geodes, I like those iridescent ones that have the big dark crystals in it that kind of glow like they're metal. Yes, sir.
Where do you find the geodes in the right place?
Well, there's a few rivers and creeks around that area down around Keokuk where you can find them. People have collected them in the Des Moines River, right along the edge of the river, but it's really a muddy business to be hiking around in there. Otherwise, there are a number of creeks in that area, but you have to get permission from the landowners to get in there and collect them.
How many geodes have you found?
How many geodes have I found? Well, I don't have an exact count, but it's probably not as many as you might guess. Geodes are cool, but I like other rocks just as well. So I've been collecting a lot of rocks. So I probably found 100 geodes in my life. Marv over here has probably found 1,000 geodes in his life or more. Probably a lot more.
What's your favorite type of geode?
Oh, I like the geodes with all the weird minerals in them. Those are really hard to find. There's some with minerals like millerite. Millerite is a long, thin, looks like a needle of nickel. Now, where in the heck is nickel coming from in our rocks to end up in there? Who knows? That's one of the mysteries of those geodes. They're really neat, but I like them with lots of interesting minerals in them.
When did you find your first geode?
I'm sorry?
When did you find your first geode?
Oh, where did I find my first geode? I think my first geode probably wasn't really a geode. It was one of those hollow concretions that I showed you earlier in the talk. But boy, I was probably about 8 years old when I did that. So that was a couple years ago.
What is the best place to find geodes?
The best place to get geodes really is at one of these geode mines, because you can go in there and collect all you want, and they're there and they're easy. You can walk a lot of riverbeds and a lot of creeks without finding any, and otherwise you're on private property. There's a number of people with private property that have geodes too. If you know somebody down there, maybe you'd be lucky and they'll have geodes, but otherwise those geode mines are pretty fun.
Thanks so much for coming tonight.
Oh, my pleasure.
I'm wondering how long it takes a geode to form.
Well, there's a good question. That's one of those mysteries that we talk about. I don't know that we can say. Obviously, you know, when you get multiple minerals in there, that means the groundwater that's been moving through carrying those minerals in has changed significantly in character. So I'm sure you're talking thousands of years to form one of those things.
Have you found like a geode with white and purple? Because I have one of those.
Well, geodes are kind of hard to tell when you first get up there. You have to be in an area that has geodes, and then you'll find these round rocks that look sometimes a little like a cauliflower on the outside, you know. So if you're in an area that has geodes and you find these round rocks, then you can be pretty sure you have a geode. If you pick it up and you're used to doing this, you'll see that a geode is actually a little lighter than it should be because it's hollow on the inside. And if you're really lucky, you hold it up to your ear and rattle it a little bit. Has a little crystal or two have broken off, and you can actually hear them rattle.
Thank you for coming, by the way. One of my questions is there technology to kind of guess like what gases made these geodes?
I'm sorry, I didn't catch the last part.
Is there any technology that is being used to kind of find like what type of gases are made with these geodes? Like you talked about the magma.
Yeah, the gases in the
bubble.
original magma. Yeah, they would mostly be sulfur dioxide and the kind of CO2, and there's a lot of things like that are in magmas when magma comes up. You know, when volcano erupts, you get a lot of gas and clouds and stuff coming up from all of the volatiles that are in it. So yeah, they've got that pretty well worked out. You get a fresh lava flow, or you get a lava flow that's relatively recent and it's cooled rapidly, it forms a glass and it really seals those things in so you can actually sample what sort of gas is inside of there. But it would be just a typical gas that you get from an erupting volcano.
How are geodes made?
I couldn't hear that, I'm sorry.
He wanted to know how geodes were made.
Like different kinds of crystals.
Well, the way those geodes form is you have a hole and groundwater slowly moves through the ground through little cracks and stuff, and it carries little minerals in, and then these minerals crystallize on the inside of this void. And then if a different mineral in, that means the groundwater is coming from a different direction, carrying something different, and has worked its way through these little cracks, and it forms these crystals around there. So it's a really long-term project.
Oh, God.
Stay by the microphone, Ray.
Okay, go ahead.
What's the funniest color of the crystal?
Depends on what kind of crystal it is. You know, most crystals are a lot of crystals anyway, are clear, don't have any color to them. But they pick up impurities that can give them all kinds of colors. Like quartz can be, you know, if quartz is purple, they call it amethyst. If it's yellow, they call it citrine.
Okay, did you show them how some of these pieces fit together to be the round rock? A lot of what's up here on the table is actually left half and right half of the same rock. So the ones that are sitting next to each other. And they look kind of like a piece of cauliflower. They're a little smooth, a little lumpy.
When we found it, you know, he picked that up, and that guy's pretty light. So we'll hit it with a hammer or a cracker. He's got a cracker. I don't have one of those fancy crackers. I use a rock hammer and crack it kind of like a coconut. You just keep tapping around the edge of it and rotating it like that, and pretty soon it goes.
Okay, oh, Mark's gonna talk for a minute.
Well, I just wanted to add a couple of things here. Several have asked about where to go to collect the geodes. And Ray had a slide up there that showed Jacob's mine. That's over in Hamilton, which is right across the river from Keokuk. So if you want to go and collect, that's the best place probably, because he's kind of set up to do collecting there. And there's several different places you can collect there. Some places you can dig in solid rock, other places you're kind of digging in a clay, so it's a lot easier in the clay. I don't have none of these are from Jacobs, but I've got a lot of them at home that are from Jacobs.
The city of Keokuk actually hosts that Geode Fest.
Right.
But it's not hosted in Keokuk, it's hosted across the river in Illinois,
In
'cause that's where
Illinois.
the geodes are.
Right, yeah. Well, this is the first year actually that Keokuk is going to do it.
Oh.
Before it was private. But, so the other thing I wanted to mention is that Ray has talked about, you know, water coming in and filling the geodes. It's not unusual to break a geode and have water come pouring out of it. And I've got some geodes that I've had 20, 25 years, and I've cracked them, and they still have water in them. And so the question always is that people ask, is that water millions of years old? I don't know that I can answer that.
Probably not.
Probably not, but it's amazing that they can retain the water for 20, 25 years and not dry up, so.
It's amazing to me that when you got a sphere like that lined with crystals like we saw, how the water gets in the first place. I mean, obviously, water comes in after the crystal rind is formed on it because you get all these other things in there. So it just takes a dinky little crack.
Could you tell us about your cracker?
Yes, the cracker I have here,
Look at this thing.
it's, there's a rock shop in Ames called Westside Agate. In fact, it's the largest rock shop in Iowa, I believe. And the gentleman that owns that, a guy worked for him for a while that made these crackers, and this is made specifically for cracking geodes. I've got one this size, I've got one that's about half as big as this, so I can crack one about the size of my fingertip there, is how small I can crack geodes. When you get to bigger geodes like this, or the bigger ones, you use what they call a soil pipe cracker, which is what plumbers use. And you can sometimes pick them up at auctions. New, they run about $600, $700. And then you've got to find something to mount it on to hold it. But if you go out on the internet under Midwest Geodes, you'll see them using some of these bigger pipe crackers. At Geode Fest in the past, they've actually had crackers down there capable of breaking some of them up, breaking some geodes that were up to 2 feet across. So, but those are very heavy duty chains, all hydraulic and everything. So the ones that we use here are not hydraulic and stuff.
Could we get you to crack one while everybody's still seated? So
Sure.
the video camera can watch it?
Sure.
And then they can all get up and watch. Or do
Okay.
whatever.
Yeah, and just the other thing I wanted to mention, Ray mentioned about the auction. I'm going to throw a pitch in for one other organization that I happen to belong to. We were out to the Devonian Fossil Gorge Saturday, and we were looking at fossils. Iowa City, actually, at Sharpless Auction in the spring, hosts the largest fossil show in the United States, fossil-only show in the United States. And the dates on that are March 29th through the 31st at Sharpless Auction. And that's strictly fossils. It's open to the public. There's no charge to come to that. And a lot of things for kids even, but there's a lot of nice fossils, anywhere from 50 cents up to 50,000 probably. So
What's the organization called again?
that's called MAPS, Mid-America Paleontology Society. And I'm president of that group here too. And we are actually centered here in Iowa City, but we've got members in about almost all 50 states, I think, and many foreign countries. So it's a large organization. So I've got some, just a few cards, or did you print some more?
I will go print some once you start
Okay.
cracking rocks.
Okay. So any other questions on the cracker here or geodes in general?
Why
Okay.
don't you do one, and so we'll let the video cameras watch, and then after that, the kids can come up and take a look up as close as is safe.
Well, Marv's getting set up. I'm going to put in a pitch for one more thing. This is not related to geodes, but one of the things that our club started last year is we started a push to make the crinoid the state fossil of Iowa. A crinoid is a kind of an echinoderm. It's related to starfish, et cetera. And we have some exceptional fossil crinoids in Iowa. So as a part of that, we need all of you to contact your legislator and tell them to do that. So there's a box back there that has a little card that'll tell you about the crinoid thing. And there's actually a little fossil piece of crinoid stem in there for your collection too. So help yourself. They're in a box back there on the table.
So if we plant it, will we grow a fossil?
Yeah, yeah. No, they're animals. They're not sea lilies.
sorry.
Although one form is called sea lilies, they look like a lily. They have a stalk and a head and little flower-like things coming out, but they're animals. They actually crawl across the seafloor.
Okay, we have one more question here. What's your question?
Is it possible that geodes could be under this building right now?
Could there be geodes in this part of Iowa?
If you went deep enough, maybe. They would be down probably 200 feet below the surface. But I don't know. I don't think that there are any in those rocks up here, but there might be.
There are some of the cold water
Oh, yeah, yeah.
up by Urbana. I have found them up there. Most often they're filled in, but quite often they are hollow too.
Cold water agates kind of form, or cold water geodes kind of form like any other geodes in limestone in a hole in the limestone by groundwater, but they're calcium, there's quartz rather than calcium carbonate like other ones that you see as vug fills and stuff. So they do actually weather out of the rocks.
Okay, you have one more question, and then we're gonna let him cut open rocks.
My aunt and uncle found a geode in the creek, like
In
a
the
lot of
creek?
them. Yeah, like a lot of them.
Cool.
Very cool.
Very cool. It's
All
always
right.
nice to find them yourself. They are all more special if you find them yourself.
Okay, now, I'll bring the mic over here in case you want to talk while you do this. But I don't have my safety gear on.
This is typically the way you find a geode. That's kind of average size maybe for a geode. They get a lot bigger and they get a lot smaller. But this cracker's somewhat limited on the size. I've got the big cracker, I could have brought that, but that takes a lot more work to move that and set it up and everything. So I just brought this one here. So the one I've got in the cracker right now is about this size. I know it's hollow, and I'm surprised no one asked about whether you can tell if they're hollow or not. Most people do it just by the feel of it, just by kind of get used to it after a while. But I've actually developed some charts or formulas for calculating how much of a void they have based upon the weight and measuring the circumference of them and stuff. And it's pretty accurate. Math, spreadsheet.
Engineers for you.
Yep. So anyhow, with that, I'll crack the geode. One of the things I'm going to do, you won't see it actually cracking because I'm going to cover it like this. And it's not so critical with these smaller ones, but with the bigger ones, when we use our big crackers, we really need to put a towel or something heavy over it and confine it, because I have actually had even these small ones split and fly off probably 10, 15 feet. Not very often on these, but on the big ones, they can really have some force. Yeah, they can draw blood if you're not careful. So that's why I use this and put my hand over it like this and then crank it down. And what this is doing is I crank it this way. These cutters, there's 4 cutters that are compressing on the geode, and they'll force it to pop. So any questions before I do that?
Here it goes.
Okay.
Okay.
Now, he's going to cover it so it shouldn't fly or anything, but listen.
You will hear it pop.
That was it. It went pop.
At least it didn't fly, right?
Nope, didn't fly. But now he's got to get it out of the machine.
Okay, now who wants to be the first one to open this? Open that up and show people what it looks like. Dump out the stuff. Yep. Okay, now hold it up for them to see.
Oh, wow. Well, all right, I'm going to say thank you guys for coming. Let's give them a hand, and then you can watch them